Greetings and welcome everyone. Today I want to show you about the fundamental properties of logarithms. And I greet you as I recently got 10 subscribers. Now, yay! So for this video is a special video, and I'm soon going to open a channel called Science for Vijay. But this video is an extremely special one, and we'll celebrate it later. But today we have explained the properties of logarithm, and first thing is a logarithm. Logarithm here. A logarithm is basically an universal exponent. So logarithm with the base of a and b, which means is equal to c, which means a raised to c to power should equal b. So this is the basic property of logarithm, property 1. And the next thing is, after seeing this property, after seeing this property as many of those knows, we'll move to property 2. And the next thing is, which means that logarithm with the base of a and b, and we flip the base, like logarithm to the base b and a. Is equal to logarithm of base b and a. But of reciprocal of these, like for example, I'm taking logarithm of base 3, 81, logarithm of base 3, 81 should equal 4, which means logarithm of base 81, 3 must equal 1 by 4. So there somewhere.
Fourth root.
So which means taking the fourth root is nothing but power of 1 by 4. No? So these things will be reciprocals always. If you flip the base and input like this, you will get the reciprocal. So that is one of the properties of logarithms. And here is the second property. Log of
Use a black book. It's easy.
Okay, but now this marker is working, no problem. Thank you. Log of 1 with any base, and this terms of basic logarithms. I'm not talking about complex logarithms which we can have advanced bases, should equal 0, as anything to the power of 0 is equal to 1. If you raise something to the 0, I'll better explain it in this way. Since my marker is horrible. Logarithm of any base 1 should equal 0 as per the standard terms, and as per the standard logarithm, but there are advanced logarithms which I will tell you later. But in a standard case, this should equal 0. As a 0, like for example, like logarithm with the base 5, 1 is equal to 0. Logarithm with the base 10 of 1 should equal 0. Ln of 1. Ln is nothing but logarithm with the base of 2.71818, so on. This is a irrational number. Is the Euler's number.
What does ln stands for? What does the n stands for?
N stands for the natural logarithm, Euler number. So if you use this as the base, then you will what will get. So basically, you learn this property, essence anything raised to 0 is equal to 1, and we are going to learn the next property, which means logarithm with the same base or argument. Like I just put 2, and here you have 2. What's the constant x to the power of 1 is equal to 1. The terms of standard logarithms is like that. I'll show more about complex logarithms later. Like for example, like 3 power 1 is 2, 3 power 1 is 3. So basically the next thing is, I'll show you a bit advanced, like logarithm of base A and B should equal logarithm to the base of C, the change of base property. This is known as the change of base property. Base C. First take a B and divide it by logarithm to the base C and A. So what I'm exactly about to tell you means, like for example, you have this log of base 381. It's nothing but log of base 981 divided by log of 3 the base 9, and here this is approximately 1/2. It means this is 2, so 2 or 1/2 here must equal 4. So hence you get it. So this is the change of.
So let me recall it. Logarithm of A, change of base, logarithm with the base C of B, logarithm of B with the base to A, and logarithm of B, change of base to the base C. Now what?
What?
So log of B with base A is equal to log of base C with B and log of base C A. Oh, is it?
Yes.
Oh, so can I put an example?
Yes, please.
So A is equal to 2, B is equal to 16, C is equal to 64.
This is easy. You chose brilliant. So which means I'll just put as
So you write your formula first.
logarithm to the base 2.
Write your formula. Write your formula. Log of base.
To base 2 16.
Log of base A. Log of base A 16. The formula is.
So I just put C. This is the answer of 4.
Okay.
So which means nothing but logarithm to the base 64. 16 over log of base 64. 2. This is 1/6. This is 1/4. So this should be 1/4 divided by 1/6. This is nothing but 1/4 times 6, which is nothing but 6/4.
Log to the 16 4 is 1 by 2.
Log
Log to the base 6. Log to the base 64. 16 is what?
this is
Not
So-
1/4. No.
let me calculate. This one 1/4. This is 2 power 4, 2 power 6. So this 6 by 4.
Hmm. Hmm.
Actually, this is no. Actually,
4 by
4 by 6.
4 by 6 by.
So 4 by 6 is this. And I think this should be approximately 1 by 6. So this is 1 by 6.
Then 4 by 6 by 1 by 6 is equal
It's
to
nothing but 4 by 6 into 6. Which means you get 24 by 6.
which is equal to 4.
Yes. So this is the change of base property. And the next thing is logarithm of base A to the power of B means this should cancel out and equal B. The reasons, like for example, is logarithms of the basic inverse. Like for example, like you have A, like you have A to the power of B is equal to C. The logarithm of the base A of C should equal B. So it's the basic inverse of exponents, which means like a logarithm with the base of A to the power of B should equal B. And here, if I just use A as A to the power of B should equal B. Like for example, and we show the logarithm with the base 5, 5 to the power of 3, 8, 5 to the power of x is equal to 5 over 3. So doing this will be satisfied with this equation. Hence, this cancels out and eventually gives us a 3. So, you have learned a few properties of logarithms, and thank you, and I find this greetings for the 10 subscribers actually. So basically is, I'll give you a killer question which I'll explain more. Q 100 Q. What is this equal? The 100th hyper operation. When you know that addition is the first hyper operation, and you keep repeating it. Multiplication by repeating it is the second hyper operation, and exponentiation, which we have, is third. And you have two types. One is lower 4L, and you have regular 4, like that. So what is the 100th hyper operation of 2? When you keep repeating this until you get the 100th hyper operation, guess what it is? The 100th operation, 200th hyper operation to 2. Any remote guess?
Infinity.
No, 100th hyper operation.
I don't know, it's a very big number.
It's a very big hyper operation.
Yes.
First, what is 2 plus 2?
See, succession. Sorry, 2 plus 2 is addition.
Which is?
4.
2 into 2?
Okay, for 2 into 2 is also 4. Okay.
And the next thing is 2 power 2.
2 power 2 is 4.
2 divided to 2
is 4. So same.
So
4. For 2 it works, but for 3 I am scared.
Yes, this is why I give you this killer question.
Oh.
The question for the 10